Hi everyone, welcome to my channel Learn Coding Easily. So today we will discuss about the queue data structure. We will discuss about the what is the queue, what are the basic operations in the queue, how we can insert the data, how we can delete, what are the basic operations which you need to understand as part of the queue. And then we will go through the code. We'll write the code in the C language. Then after that, we will just see what are the applications of the queue data structure. All right. So let me share my screen. Give me a minute. All right. So first thing is, what is queue? Queue is nothing but a linear data structure which will follow the property first in, first out. What it means? Okay, whatever things you will insert the first, those things will come out first. Okay, so the real life examples I can give is, let's say you are standing in a queue to take money from ATM. Okay, what will happen? The person who will come first, that person will get the access to ATM first, right? So the first come first out, he will take the money first and then he will come out. So here there are some images you can see. Let's say you went to the ticket counter. Okay, there is long queue is there. So the person who will come first, he will get the ticket first and then he will go, right? Similarly, you can see there is one more. Here you can take any example. Let's say for the vaccination you are going. The person who will come first, he will go first, right? So this is the ideal situation, that everything, the person who will come first, he will go out, and always we will insert from the last. So that any new person will come, he will stand in the last on the queue. All right. Now you will say, sir, okay, I can go and I can stand anywhere. No, that is not the ideal situation. Okay, so let's say you will go to the ticket counter, you will try to stand in between somewhere. All the people will shout at you, hey man, go back, right? So we will talk about the ideal situation in which you will always stand at the last in the queue, and the person who is standing in the front side, he will get the ticket and he will come out. All right. Now let us jump to the basic operations of the queue. Basic operations of the queue are nothing but insertion. So here insertion is also known as enqueue. Okay. And deletion is also known as the dequeue. And we have peak. Peak will always return you the front element of the queue. And we have the full and the empty. Your queue is full or queue is empty. So these are the 5 basic operations in the queue, I can say. All right, let me explain you the, okay, let us jump to the coding part directly. I will write the code in the C language and I will explain you how we can implement our own queue. All right. So to implement a queue, what you can just take one array. All right. We will take one array and we can choose one variable which will denote the maximum size of the array. Apart from these two, we need to take 3 variables. One is the front pointer of the queue. One is the rear pointer of the queue. One is your size, means how many elements are present into the queue. All right. Don't worry, we will understand everything, why we need size, why we need front, why we need the rear pointer. Now here, let's say you want to insert something to the queue. What you will do, you will call a function called enqueue and you will pass the value which you want to insert. First thing we'll check, hey, if the queue is full, we cannot insert, just return. If the queue is not full, we will always insert the element at the rear index. Okay. And before doing that, we will increment the rear by 1. Now, the very important thing is rear is by default is max size minus 1. So here max size is 10. So rear is nothing but max size minus 1. Here, due to the syntax issue into the C language, I have written this way. Okay, but in actual, what you can do, you can put this complete piece of code inside the main method, and you can pass the array in enqueue function as well. But just to make the things easy for you, I'm just putting everything outside so that you will understand the things easily. All right. Now what we are doing for insertion, we are always inserting the data at the rear index. All right. Now let us talk about the deletion part. We will always delete from the front side of the queue, right? So where is the front side? Front side is the area of front. And once we have deleted, we need to increment the front by 1. Okay, this is all about the insert and the delete functions in the queue. Now, still not clear, let me explain you with the help of example. Okay, let's say here, we'll take the same example. Now, for example, this is our queue. Okay, this is our queue. So this is our queue, let's say. Now here by default front is 0 and the rear is pointing to the 9. Okay, in this starting, these are pointing to the 0 and 9. Now you want to insert the 10 into the queue. What you will do, you will just insert the 10 here, right? Once you will insert the 10 here, your front is already 0, right? Your rear will be what we are doing, rear plus 1 modulus max size. So 9 plus 1 more 10 will be 0 again. So this time, once you have inserted 10 into the queue, your front and rear both are pointing to the 0th index, right? Let's say you want to insert the next element, 11. What we will do, this time we will not modify the front will still be 0. We will increment the rear by 1 and we will insert the 11 at the index number 1, right? Now, next will be, you will insert the 12 into the queue. And again, you will increment the rear pointer, front will still be pointing to the 0. All right. Now, next you will insert 13 into the queue. Okay, so 13 into the queue you will insert. Your front will still be pointing to the 0. Your rear pointer will become 3. Understood? So this is how we have done the insertion part. Now, whenever you want to delete, we will always delete the front pointer. So let's say you will delete this 10. Now, once you will delete the 10, what you need to do, your front is pointing to this particular number, which now, since it is no longer present into the queue, your front should point to this one, right? So we are incrementing the front. That is the reason while deletion, we are incrementing the front pointer, you can see here, right? We will delete the front element with help of array of front and we will increment the front by 1, right? Let's say you want to delete one more. What you will do? Okay, your front will point to the next element into the array. So your front will point to the next element into the queue, right? So this is our front, this is our rear pointer. Rear pointer will always point to the last element in our queue. Okay, so two important things. Insertion we will do from the rear side. Okay, and deletion we will always do from the front side of the queue. Okay, let me jump to the code again. So I hope these two are clear to you. In case of insertion, increment the rear pointer by 1. In case of deletion, increment the front pointer by 1, right? Peak will always be the front element. And how to check the full and the empty. So we have taken one variable called size. Why we are taking the size? Just to implement these two methods. So if size is 0, it means that your queue doesn't have any element. It means it is empty, right? And if it is full, it means your size reached to the maximum size of the queue. It means it is full. So in every insertion, we will increment the size. In every deletion, we will decrement the size. You can see the code also. Here, in case of insertion in queue, we are incrementing the size by 1. In case of deletion, we are decrementing the size by 1. All right. So what I will do, let me just do one thing for you. Okay, I will just increment the size of this box. Okay, please take the screenshot. Let me scroll down. Now take one more screenshot. I hope you took a screenshot. You can just write down the code by yourself or just do the typing. Okay, just type the same piece of code. You will understand everything very easily. All right. So this is all about the queue, how we can implement our own queue. We just need to take one array. We just need to take 3 pointers, front, rear, and the size. And with the help of these three, we can easily implement the basic operations of the queue. Now, what are the applications of queue? You will say, hey, we got the idea about the queue. Now, why do we need the queue in the real life, right? So when we talk about the applications of the queue, so you have seen the tree. In case of tree, whenever we'll talk about the level order traversal, okay, it means in case of tree, in case of graph, anything which you want to traverse level by level, or also known as the breadth first search, there without queue we cannot do it, right? So in case of tree traversal, level order tree traversal, you need to use the queue. That is the one of the most important use of the queue, right? Second thing, in case of operating system, whenever you have the limited resource available, okay, right, whenever you have, let's say, a lot of tasks are available, now your CPU doesn't have that much okay, let's say the right, so resource. Now what we will do, we will just give the resource based on the request. If you will send the request first to me, I will give the resource to you. So there also we need to use the queue, okay, just to manage the resource, right? In case of scheduling also we need to use, in case of simulation also you need to use. So these things are actually very important for the software, okay? So I hope you got the idea about the queue, what is the queue, how we can implement it, what are the basic operations of the queue. Now once we are done with the basic part, we will go through the some of the important interview questions in the queue. So in my future videos I will be uploading some of the important questions of the queue data structure. So please stay tuned for those videos. And if you like my content, please like, share, subscribe. Thank you, everyone.